Well, pre-calculus classes, good morning, good afternoon, or good evening. We are going to move into section 6.2 now. There are a lot of parallels with it along with section 6.1. So if you do have your 6.1 notes handy, I would certainly keep those close by because we will probably refer to some of the topics from those. So what we are going to do in 6.2, we're going to talk about what was known as the law of cosines. In 6.1, we went over what is known as the law of sines. So if you've already printed off 6.2, you can see that we are asking you to solve a triangle where side A is 31, so there's angle A. Side B is 52, there's angle B. Side C is 28, there is angle C. Well, if you were to try to set this up using law of sines, you are going to end up with an issue. So like if I tried to take sine of A over 31 equals sine of B over 52, well, that's not going to be possible. You have two variables within one equation. If I tried to use C, same issue is going to emerge. So we have to use something else. The other option, when you have this situation where I have side, 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 you have to use, where all three sides are given, the law of cosines. So in terms of what we are going to do now is law of cosines, and it looks familiar when you see that formula. It's just going to have an extra item that you've never seen before, and that is the law of cosines is c squared equals a squared plus b squared minus 2ab cosine angle c. Well, again, if you cover this portion up, basically what you're dealing with is the Pythagorean theorem. Now, the reason that you've never seen this part before is if you're working with a right triangle, well, the cosine of 90 is 0. So that's why this part is something you've never worked with. Now, the law of cosines, kind of like the area of a triangle formula, where I know I wrote out the two additional forms. Basically, you know, if you're working with side C, you're going to do a squared plus b squared. If you're trying to find side B, you can do a squared plus c squared minus 2ac cosine angle B, and then a squared equals b squared plus c squared minus 2bc cosine A. So whatever side you are isolating, you'll do the cosine of that angle. Here, b squared cosine of b, a squared cosine of a. And notice these two sides, a and b here, will always show up here. A and C, b and C, b and C. So that's one of the things that, you know, you're really only using one formula, but there are three variations of it. So in terms of this triangle right here, I always recommend in a side, side, side situation, find the largest angle first. There's a reason why you will find that helpful, which we'll talk about here in a moment. So I am going to start out finding angle B. So that means I am going to use this middle version of the law of cosine. So b squared, 52 squared equals a squared plus c squared, so 31 squared plus 28 squared minus 2 times 31 times 28 times the cosine of angle B. Now, from here, you do end up with some fairly large numbers. So 52 squared is 2704. You do have to be careful when you are working with the law of cosines about how you enter things into the calculator. Do not try and enter this all at once. You can certainly add these two values up and then minus 1736 cosine B. The most commonly made mistake is right here. I cannot take 1745 minus 1736 equals 9. If you do that, you are going to end up with an incorrect answer, because the multiplication here is why I cannot combine those. So what I'm going to do, subtract off the 1745. I end up with 959 equals. Now, here's the next most common mistake that's made with this. Don't lose that negative sign as you bring that down. Now I am going to divide. And when I do that, I get negative 0.552 equals cosine B. Now, to get angle B, I am going to take my inverse. And it's around 123.5 degrees. Now, the reason I like to find that largest angle first, if you have the law of cosines, it is impossible to have a second answer that works. And the reason, if you remember, going back to 5.5, that additional answer from cosine comes from subtracting either 2 pi or 360. So if I were to take this answer and subtract it from 360, I end up with like 236 degrees, which there's no way that answer can be within a triangle. So that's the reason, always find the largest angle first in a side-side-side situation. Now, to finish solving out the triangle, I'll go ahead and put this answer in. Now I can find either A or C. You have two options now. You certainly could do law of cosines again. Now that would not be my option. Or I can use law of sines. That's going to be a little bit easier in my opinion. Now it doesn't really matter which angle you find next. I'll probably go ahead and find angle A. So when I do that, sine of A over 31 equals the sine of 123.5 over 52. So again, I am going to cross multiply and divide. And when we do that, the sine of A equals 0.497. So again, we'll take our inverse, and when you do that, it's around 29.8 degrees. So we now have our second of the three portions we need for solving the triangle. Now, to get your third angle, obviously you now have three options. If you really wanted to make it ugly, use law of cosines. You could do law of sines again, but no reason to. We'll just take that angle C is 180 minus 123.5 minus 29.8, and that is 26.7 degrees. All right, one other example, and then we'll move on to another area formula option that you have, is example 2. So here side B is 18, side C is 10, angle A is 110 degrees. Well, go ahead and set up our sketch. we'll use an obtuse angle there of our two other sides. 18, 10 fit best that way. So again, we're going to find the missing sides and angles. Now, to start out, what I am going to need to do is find side A. We are going to use law of cosines for this, and since I'm finding side A, now it's actually going to be a little bit easier. I'm just going to use the a squared equals b squared plus c squared minus 2bc cosine A, and I realize now I left out AC when I wrote that out. So, alright, so a squared equals 10 squared plus 18 squared minus 2 times 10 times 18 times the cosine of 110 degrees. Now, unlike the last one, when you're solving for an angle, you cannot enter that all into your calculator at once. When you're finding a side, you can, because you don't have any order of operations issues show up here. So 10 squared plus 18 squared minus 2 times 10 times 18 times cosine of 110 is 547.13. And then to find side A, all we do is take the square root, and that final side is around 23.4, which again, you can always kind of look at what you're given and see, does that fit? Well, it's across from the biggest angles, so yes, that side should be bigger than the other two, which it is. Now, from here, we do need to find angles B and C. Again, you've got a couple of options. I'm going to go ahead and find angle B next. You can either use law of sines or law of cosines. When I have the option, I do use law of sines. I think it's a little bit easier, especially when you're trying to use it to find an angle. So, the sine of B over 18 equals the sine of 110 over the 23.4 that we just found. So again, I am going to cross multiply. And divide by the 23.4. And when you do that, you get around 0.723. So the sine of B is approximately 0.723. We will take our inverse, and it's around 46.3 degrees. Now the good news is, since you were given side angle side, we don't have to worry about an ambiguous case. There is not a second possible answer for this. If you subtracted that from 180, it's like 133 degrees. Well, there's no way you could couple 133 and 110 and still fit within a triangle. So all that's left now, subtract things from 180 to get angle C. And it's 23.7 degrees. So again, you can see that as the angles get smaller, the side lengths across from them all kind of fit together logically. So those are a couple of examples of how the law of cosines work. The final thing from section 6.2 is what's called Heron's formula. Now, that is used to find the area of a triangle when three sides are known. So, side, 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 we use Heron's formula. If you have side, angle, side, we use that kind of variation of 1/2 base times height, the 1/2 BC sine of the included angle. Now, when you know all three of these sides, you have to find this quantity s, where basically you add up all three sides, divide by 2, and then you will take the square root of that value, and then you take that value and subtract all three side lengths, multiply them all together, take the square root. So, if you have a triangle where the sides are 5, 4, and 7, and we're going to find the exact area of that triangle, well, first thing we're going to do is find s. So I'm going to add up the three sides. 16 divided by 2 is 8, and then take the square root of 8 times 8 minus 5 is 3, 8 minus 4 is 4, 8 minus 7, no, you don't technically have to write that out, but just so you can see where everything was coming from, I want you to see that usually there are going to be three different values there. Now, from here, when you take 8 times 3 times 4, it is the square root of 96. Now, the one thing you do need to be careful about here, it did say exact area. So, that means we are going to need to simplify our radical. The largest perfect square that goes into 96, I know, is 16, so that is for square root of 6 units squared. Now, if it wants an exact answer, that would be what you would have. If it does, on Pearson, say round it to the nearest tenth, then yes, you can say it's around 9.8. So, just kind of be aware depending on what you are asked for. If it wants an exact answer for radical 6, if it does say round it off to the nearest tenth or whatever unit, you can certainly do that. Again, 6.2 also has an assignment on Pearson, and these were the notes to accompany that.